Imagine a world where the very air around you is, well, alive with intelligence. Welcome to this explainer. We're going to investigate how an invisible web of next-generation 6G infrastructure is literally about to change urban life forever. We're looking at a breakthrough here that merges material science with information technology, basically rewriting the laws of physics as we know them. Let's dive right into this with a high-stakes scenario. What if a concrete wall wasn't just a passive barrier, but a silent guardian? Think about it. What if a simple utility pipe buried deep underground could actually feel the heartbeat of the city and do it all without a single camera? I know, it sounds straight out of a sci-fi movie, but this is the very real 6G technology being forged right now. So our mission today is to decode exactly how this is happening. We're going to explore how China is bridging the physical and digital worlds to build what they call a distributed intelligent architecture. And look, this isn't just about getting faster download speeds on your phone. It's about creating an environment that actively protects and manages modern urban spaces in real time. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. China's award-winning 6G tech turns every wall and pipe into a sensor. Chinese innovation boosts wireless data rates, reduces dead zones, and can track people and objects even underground. With that said, let's go straight to the intro. The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. One like, one subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much. To really wrap our heads around this, we have to start with the architects. Meet academician Cui Tiejun and his powerhouse research team at Southeast University. These guys have engineered what was once considered the absolute holy grail of wireless technology. You know, while most of the world is still just trying to figure out how to optimize 5G, this team, they've been quietly building the foundation for an entirely new paradigm. Now, a vision like this doesn't just happen overnight. Back in 2014, Cui Tiejun's team was the first in the world to propose digital metamaterials. These are basically materials engineered at a sub-wavelength level to do things nature never even intended. Fast forward to 2026, and this exact concept evolved into a 6G infrastructure that took home a gold award at the 51st Geneva Exhibition. So, what exactly won them that shiny gold medal? The core of this breakthrough is an acronym you're absolutely going to want to remember: DICEM. That stands for Distributed Integrated Sensing and Communication Metasurfaces. It's a mouthful, but essentially it's a physics-spanning technology that literally turns everyday, boring passive infrastructure into a highly intelligent, active network. The best way to think of DICEM is like a smart skin. Picture these really thin, flexible electromagnetic coverings that you can just wrap around building facades, interior walls, or even structural piping. See, ultra-fast 6G signals like millimeter waves are notoriously fragile. They completely hate obstacles. But instead of blocking the signal like a normal wall would, these smart skins act as software-defined mirrors. They catch and steer the radio waves exactly where they need to go. And the sheer scale of this improvement, it's staggering. Just look at the data from Southeastern University's field tests here. While a traditional wall causes a massive drop in signal, leaving you completely disconnected, the smart skin generates an active power boost of 10 to 20 decibels. To put that into perspective, we're talking about deep shadow zones that used to be completely dead at 0 megabits per second, suddenly blasting 400 megabits per second. They are literally bending the waves around corners. But here's the crazy part. It's not just about communication, it's about perception. Data from the 6G DICEM project reveals some truly astonishing localization accuracy. In low-frequency ranges, it tracks objects down to 0.1 meters, but in high-frequency ranges, it dials into an incredible 0.01 meters of absolute positioning. That is surgically precise. I mean, the infrastructure literally knows exactly where your hand is, not just what room you're standing in. Moving on to Section 1, Semantic Sensing, or Camera-Free Tracking. So how exactly do you sense human life with that kind of surgical precision without using a single camera? Well, the secret lies in the methodology. The system uses high-speed switching to generate spatially distributed harmonics. Essentially, this turns your walls into radar probes. Step 1, they track physical disturbances in the radio waves, which engineers call channel state information. Step 2, Edge AI jumps in to analyze these temporal variations, actually learning to distinguish a walking person from, say, a falling person, based purely on radio waves. And finally, step 3, it extracts what's called semantic state. And right here is where the privacy revolution happens. Instead of transmitting invasive visual video of you sitting in your office or bathroom, the AI simply extracts the meaning. It sends discrete alerts like room occupied, pedestrian flow detected, or crucially, possible distress fall. It totally strips away your visual identity and only keeps the data that actually matters. Which brings us to section 2, the urban digital twin, the city's living digital mirror. Because these sensing nodes are literally everywhere, wrapped around pipes, baked into walls, they feed invisible signals into a central hub, creating a real-time, living digital mirror of the physical city. And this allows for what can only be described as God-level city management. The network can track passive, unconnected pedestrians. Yes, meaning people who aren't even carrying a smartphone. It optimizes traffic flow, protects vulnerable cyclists, prevents collisions for autonomous vehicles, and even coordinates medical emergency services with surgical precision. Imagine someone collapses in an empty utility tunnel. The pipes themselves can call the ambulance. It's wild. Now, let's look at section 3, the shield, focusing on privacy and secure architecture. But, with infrastructure that thinks and feels, we have to face a really critical tension. How does this architecture protect you from just becoming an exposed data point? Well, the answer is abstract data. By transmitting only semantic states rather than raw, high-risk wave patterns, the system ensures your personal, highly detailed wave signature never actually leaves the local room. The heavy lifting is done by local edge processors right there, so the central system only ever knows that someone fell, not who fell. Furthermore, the physical security of the signal itself has been completely revolutionized. Researchers at the City University of Hong Kong, collaborating with the mainland team, have developed the world's first universal metasurface antenna. This thing basically serves as a digital fortress. It's an absolute beast of a machine that can manipulate all 5 fundamental properties of electromagnetic waves simultaneously, and it does it entirely via software. This invisible shield relies on something called direction modulation. The antenna steers a signal so precisely that the communication channel is inherently eavesdropper-proof. You literally cannot intercept the radio signals used for this sensing. They're treating privacy not as some afterthought, but as a key performance indicator baked right into the physical layer of the network itself. Finally, section 4, next steps. The 6G era has arrived. So what actually comes next for this paradigm-shifting infrastructure? We are looking at a system that fundamentally merges material science with information technology. The era of 6G isn't just about faster downloads, it's about creating a fully intelligent, responsive environment. And believe me, the global community is watching intently. Out of over 1,000 incredible inventions from 35 different countries, this 6G DSAC technology stood at the very top, taking home gold in the 2026 Geneva Exhibition. The world is recognizing that this distributed intelligent architecture is the dawn of the next great technological leap. I wanted to leave you with this provocative thought. As we step out of the 5G era and into this distributed intelligent world, are you ready to live in a city with sensing pipes and smart skins? Like, is it comforting to know your walls are watching out for you? Or does it feel a little too much like The Matrix? Your next steps are to drop your thoughts in the comments below. If you found this explainer as mind-blowing as I did, definitely smash that like button and subscribe to the channel. Also, let us know, should we explore those new brain-computer chips that also just won gold in our next explainer? Thanks so much for watching, stay curious, and goodbye.